Hi, I'm Daniel, coach of Team Capgemini, with our customer Konstantin and Fedor, our team lead Jan Philipp, and our amazing developers team who worked really hard throughout the semester and did a great job. And now, let's start.
Good evening, everyone. My name is Anna, and I'm a quality inspector in the car industry. Every day I have to inspect numerous car parts for damages that could have occurred during production. So let's take a look at this dashboard. Oh my, there's a scratch. Yeah. I have to write every step down. I have to measure it. Yeah, 4.5 centimeters. Yeah, and then I have to describe the exact location of the damage in order the repair mechanic to find it and to fix it. So this one is...
Hey Michael,
50.
Great job. It's already your 10th dashboard today, and keep it up, man. And I just no, you're so slow.
What? How can this be possible? He's been playing on his iPhone the whole day.
I need way less time since I have been using the Capgemini app.
Using what?
Using Capgemini. As you've seen, quality assurance in car manufacturing is a very hard and time-consuming task right now. You have to locate, classify, and report damages in order to forward them to a responsible repair mechanic later on. This whole process of information sharing is done by hand right now. This is of course very inefficient, and still you have the probability of missing a damage. With our app, Capgemini, we wanted to improve this process by first of all scanning objects like our dashboard right here in an augmented reality environment. This should then allow the worker to annotate damages. Further, we wanted to achieve that our app automatically detects damages. For that, we use machine learning. As I said, after creating incidents for all the damages that he found, the quality inspector needs to forward them to a repair mechanic. The repair mechanic himself should then be able to relocate the incidents. And finally, after fixing the damage, he should be able to mark the incident as resolved. So that was our basic plan. Let's see how this works in action.
All right, Michael. So what is this app about?
First, I have to move my camera to let the app recognize the car part. Once it's recognized, its name and further information are displayed on the plane in AR. Now I can look for incidents and annotate them. The app can even spot damages automatically. I just need to turn on this feature. As soon as a damage is recognized, I can create a corresponding incident. And furthermore, the app Capgemini can tell apart different types of damages. Look, it just detected a dent.
All right, that's amazing, but how does the automatic detection work?
That's actually a great question. As you've seen, our app locates and automatically annotates damages, or in our case, there were icons. To achieve that, we created our own custom machine learning model using TensorFlow's object detection API. Afterwards, we converted it to a Core ML model, which is usable in Swift. So, what do you need to create your own TensorFlow model? Basically, labeled data. In our case, those were around 500 pictures that we took of those icons. We just used those icons because obviously we cannot destroy that dashboard. After taking the pictures, we were able to label them. So we basically told TensorFlow where in which picture is which icon. Having done that, we could start training and testing. Did that in a Google Cloud for around 12 hours. And now the converted model provides us information about what icon could be detected to what percentage. Beautiful. That shouldn't happen, should it? Awesome. Could be detected to what percentage? As a final step, now I'm here again, we added a feature that if we receive a perception with more than 90%, we just create an incident automatically by tap. And that's basically what Michael just did. I think now it would be great to get into a few more detail regarding that incident.
By tapping on the pin in AR, I can view the details. Look, the size is already measured.
Oh, that's amazing. Well, I'd love to try it out.
Perfect. I happen to have my spare phone with me. Just take it. First, you have to scan the dashboard so that the app knows that we're working on the same object.
All right, so the dashboard is detected.
Yeah, now I'm activate multi-user.
Oh, amazing. I can see everything you've already documented. But look, what's that?
No worries, just annotate it by tapping on the correct spot.
Okay.
Perfect, I can see it.
Okay, now I want to change the information. Well, I want to take a photo. Smile. And I don't like the description. Yeah, I'll put a smiley there. Okay, I'm done.
Perfect, now I can see everything you're working on. Look, sometimes the pictures need some time. Ah, perfect. What a great picture.
Oh, that's really nice. I have to tell my boss I'm now much faster. But, well, I still don't understand how the dashboard is detected and how can we put pins on it?
Maybe I can help you guys here again. First of all, we have some 3D objects saved to our app. If the camera now detects one of those objects, a corresponding anchor is placed in a 3D environment. Additionally, we had an info plane showing all the important information like the name. To now create an incident, we mapped the 2D hit location on the touchscreen onto one of those yellow 3D feature points that you might have noticed before. Additionally, we had a pin so that the incident is visible. The pin's position again is computed relatively to the dashboard to make sure that we can share it and relocate it later from another device. Beautiful. Sorry guys. As a next step, after creating incidents, our process now requires sharing and later on relocating them and resolving them as a repair mechanic. To show you what we achieved here, let me introduce Daniel. He's repair mechanic at our repair garage and now wants to fix all the damages on the dashboard.
Hi Daniel, I'm done finding damages. I already shared them with you.
Perfect. Let me open the app. First, I have to scan the dashboard to relocate the open incidents. Perfect. Well, looks like I just found an incident right here. Ah, cool. And the quality inspector even left a photo for us. Let's fix this incident and mark it as resolved. Let's go to the list here. But where are all these incidents located? With help from this navigation feature, the app can guide me to the open incident. Ah, perfect, there it is. Let's fix this incident and mark it as resolved. Two more incidents missing. Well, I got time for one more. Well, this one is too hard for me to solve right now. Let's do it tomorrow. This app really made my life easier, but wouldn't it be nice if the app also could help me to fix the incidents?
That's a great point, and it brings us to future plans and problems we face during development. As correctly noted by Daniel, the app is still missing a suggestion component because we were restricted by the hardware we're using, which is currently iPhones and iPads only. By adding a server-side component, we could not only store data persistently and use them as basis for our suggestions, but also introduce a notification service and increase the range of multi-user collaboration and incident sharing. Some issues we ran into were mainly related to the nature of the damages that we're dealing with. Unobtrusive damages, such as scratches and dents, usually don't have a clear shape or form, so teaching our model to identify them correctly would take a lot more than 500 pictures and 12 hours of training. Also, since these damages are often very subtle and small, relocating them in our AR environment can be tricky if annotation pins are not set precisely enough, which is something that we're still struggling with. To summarize, our app is a great prototype to demonstrate what technology, such as augmented reality and machine learning, is capable of. But for this app to be deployment ready, there are still some steps to take. I hope you've enjoyed our presentation. Thank you very much. Now to our customer.
Yeah, thank you guys very much for your presentation. You have showed us a lot of features. It quite exceeded our expectations. For us, it was very important to see where also the limitations of the technologies are. And I'm happy to discuss this tomorrow over a nice dinner. And I'm looking forward to your research proposals. Maybe you want to write a bachelor or master thesis. So thank you very much again, and great work.